Good morning, everybody. So my name is Will Rhodes. I'm the Director of Carrier Managed Service Partners in EMEA. And I'm really pleased to be here today to be talking about a topic very close to my heart. And it's obviously it's a conference in 2024, so we have to talk about AI. But really, what's close to my heart is how can service providers make money from this particular innovation. So I have a confession to admit. So I was in my hotel room this morning, and I was a bit panicked. I have to write an introduction. So I was like, I'm doing a presentation on AI. I tell you what, let me use AI to help me write my introduction. So here's our conversation this morning.
Morning, ChatGPT. How are you today?
Morning, Will. I'm doing great. Thank you for asking. How about you? Ready for your presentation at the GCCM conference?
I'm really excited to be presenting in such a distinguished audience, particularly around the topic of AI and its impact on the network. But I realized I've forgotten to write my introduction. I was wondering if you could help me write a short introduction for the presentation, please.
Of course, I'd be happy to help with that. How about something like this? Good morning, esteemed colleagues and industry leaders. I am Will Rhodes, and I'm honored to be here with you at the GCCM conference to explore a topic that's transforming our industry: artificial intelligence and its impact on the network. Together, we'll delve into how AI is not just reshaping our networks, but redefining the future of connectivity. How does that sound?
That's great, thanks.
Isn't it great, AI? It saved me this morning. And there's the nice little introduction for you. So today we're really going to be focusing on this dynamic shift in our industry and how service providers can take advantage of this. I'm not going to linger too much on some of the operational efficiencies and digital transformation elements, but more about that revenue generating piece. So quick bit about AI. I mean, I'm not going to teach you about AI. I think many of you know this already. But that was obviously ChatGPT. And the interesting thing about ChatGPT is it only took 2 months for them to get 100 million monthly users. And there's a latest one, Threads, which is from Meta. It only took them 10 days to reach that same level of user base. Now, I'm not going to read the slide out to you, but you can see some of the other platforms that we use in our daily lives. And it just shows you how long those took in comparison. And whether you're using Copilot, whether you're using ChatGPT, whether you're using any other AI platform, we're using this and embedding this in our daily lives all the time. And it's only going to accelerate and increase on an ongoing basis. And for me, this is really about generative AI is the next wave or the next platform shift that we're going to see in our industry. We saw this in the 80s with mainframes, more recently with smartphones and cloud, and now the latest generation is they're moving towards generative AI. And the thing about generative AI is it's actually generating these real-world use cases. So if you're, for example, looking at healthcare, AI is actually able to identify cancerous cells much quicker, much more effectively than a human counterparts. If you look at financial services, they're able to identify fraudulent transactions much quicker than any sort of machine learning or human interface would have done in the past. And that has an absolute benefit to the bottom line of those financial services organizations. And so the adoption of AI is just absolutely accelerating. And governments are waking up to this. In Australia, for example, the Australian government are investing a huge amount of money at the moment to build out the disaster recovery as a backup for all of these AI instances. And they believe that's going to add $6 trillion to their GDP by 2027. More locally, in Oman, for example, we've got the Institute for AI and Advanced Technologies. There's a similar government organization being set up in Saudi Arabia at the moment, because they see this as a way to diversify their economies and a way to build economic growth for the future. But obviously, underlying all of this is the actual physical infrastructure. And that's what I'm going to talk a little bit more about today. So I think many of you have heard of a small company in the US called NVIDIA, only turned over $26 billion last quarter. Now, that was 260% increase year on year. Now, that's just one player in this marketplace. There are others like AMD, Intel, the startups, many companies that are building out these GPUs, which I'll talk about a little bit about in a second, to build out to support this wave of innovation in AI. And who's buying this? Well, obviously, there's the big hyperscalers, the Meta, the Microsoft Air are buying a vast majority of them. But there are many, many, many smaller companies and startups who are buying these chips. And the lead times on these are just getting longer and longer and longer. And many of them are in excess of 12 months now. So hence the reason many of the hyperscalers are actually starting to invest in their own chip development to be able to satisfy the need of these new infrastructure build-outs. So let me tell you a little bit about CPUs versus GPUs. This is a masterclass, did a little bit of education. You can go home back to your companies. I've learned what a CPU is versus a GPU because many people hear about GPUs and they don't understand it. So I'm going to show you a very short video right now. This is from Mythbusters. So this is a documentary series. It's about 12 years old, fun enough, sponsored by NVIDIA. And it talks about what a CPU is and a GPU. So think of a CPU like a paintball gun trying to paint a picture. It does one individual task thing at a time, and that's the sequential processing. Now let's compare that to how a GPU works. A GPU is like hundreds or thousands of paintball guns put together, painting the picture all in one go. So you can see it's a bit of a silly example, but a sequential processing it can be very inefficient when you're trying to do lots of processing in one go, whereas the GPU is much more efficient at doing that processing. The counteract to that is it's very hungry on energy, and we'll touch on that a little bit more in a second. When you look at the servers globally and what they're being shipped for, you can see this chart on the left here. This is global shipments of servers. And you can see back in 2019, AI applications was relatively low in comparison to others. But you can see the sort of hockey stick situation going on at the moment. And Omdia are forecasting by 2029 that artificial intelligence applications will be the largest application for servers globally. And then if you boil that down in terms of what they're being used for, obviously a large amount of that is on the right-hand side. You can see the pink line is for those large training models. And obviously, there's a lot of investment going in there. So ChatGPT, which you saw a second ago, they're doing ChatGPT 5 at the moment, and that's reportedly costing $1.5 billion of investment to build out that training model. However, once you've got that model built, once you've got those GPUs installed in your data center, you can repurpose those GPUs time and time and time again. So that is why Omdia are forecasting that the server shipments for training is going to be relatively flat. But actually what Nabil and others were talking about in the panel earlier was it's around training and getting those GPUs much, much, much closer to the end user. That's where we're going to see the biggest amount of growth in the future. So where are those GPUs going? Well, as the panel said this morning, 90% of the investment globally is going into the US at the moment. And this chart that you see here is basically showing the amount of power consumed by data centers from North Virginia, where there's a real hotbed of activity, versus some of the Asia-Pacific data centers as well. And you can see that in Northern Virginia, you've got 11.3 gigawatts of power, which is more than all of the large cities combined in those yellow boxes. So Mumbai, Sydney, Shanghai, Beijing, Tokyo, all of that combined is the same amount of capacity as Northern Virginia at the moment. So there's a lot of investment going into North America and particularly North Virginia. But the challenge that they have is they're running out of space and power. So hence the reason there's a huge investment to build out outside of Northern Virginia, but also in other parts of the world as well. Let me give you an example of this. You may have heard of an individual called Elon Musk. I know he's not very well known. A few of you might have heard of him. Anyway, he created a new startup called XAI. And he built one of the largest training clusters in the world, in Texas, in 122 days. And kid you not, he installed 100,000 H100 GPUs in 122 days. And by this time next year, once the H200s have been shipped to him, that will double in size. And let me show you what that looks like. So this was day one of the installation. And this was 122 days later. So you can just see the scale of investment here and the scale of speed and velocity that people are investing in this particular area and building out these very, very large training facilities. But let's look a little bit closer to home. So obviously there's these big booms all over the world, but there's a significant opportunity and a massive investment going on in the Middle East at the moment. According to 451 research, there are 9 cloud on-ramps in the region at the moment, and there's 3 further invest in the not too distant future. You've seen, for example, AWS announcing a $5.3 billion investment in Saudi to build out a region in the kingdom earlier this year. And we're starting to see more and more of those hyperscalers looking to build out those regional plays as well. Currently, 451 are tracking 1.4 gigawatts of data across 180 data centers in the region, with a further 1 gigawatt either under construction today or planned. Now, we, Ciena, are aware of a further gigawatt of capacity that's not tracked in that 451 data. So you can see there's over 2 gigawatts of capacity, so tripling the size of the current landscape at the moment. So there is a huge boom going on in terms of building out the physical infrastructure in this particular region. But obviously, space is only one factor in this. There was talked about this on the panel earlier. There's actually 3 key elements, or I call it the trifactor of building a new data center. And physical space is only one portion of that. You need energy. You need a lot of energy. And again, I'll touch on that in a second. That needs to be cheap, but also ideally sustainable in today's world. But actually, you can't have 2 of the 3. You've got to have all 3 elements. You've got to have that connectivity and data flows. You've got to have that connectivity back all through both the terrestrial, the dry systems, but also the subsea elements as well. So let's dive into the energy piece. Why is it so important, the sustainability and the cheap energy? Well, if we look at our CPU environments, that sequential processing that we showed a second ago, there's about 10 kilowatts. That's a high-end server rack, right? Many of them are single digits. But actually, when you start looking at AI and training, those hyperscalers and enterprises that are buying those GPUs are now requiring anywhere between 100 and 200 kilowatts per rack. So you're essentially looking at 20x the amount of power for the same footprint as you needed in your more traditional data center. And the challenge that many data center providers have is that in those traditional markets, so North Virginia, in Europe with flat D, so Frankfurt, Amsterdam, Paris, London, and Dublin, there just isn't the space and the power to be able to cope with these new wave of innovation and new GPU deployments. And let me just double click on that a little bit more detail. And again, it was alluded to on the thought leadership panel earlier that estimates vary, but anywhere between 1% and 4% of global emissions are coming from data centers today. Those are varying, but nonetheless, it's a significant proportion or a contributor towards the energy emissions globally across all different verticals. And my little silly video at the beginning with my ChatGPT conversation, that cost anywhere between 25 and 30 minutes of a 5-watt LED bulb to run. So that's just one silly little video that took 30 seconds. And that was used a huge amount of energy just alone. And you can imagine you're trying to build a blockbuster movie, or you're trying to analyze the genome, or trying to identify cancer. It's going to take up a huge amount of energy. So these growing large language models, or these neural networks, very, very, very expensive to deploy, and they have a substantial economic footprint. So with adversity, that creates innovation and opportunity. So, for example, one of the things that we're working on in Ciena and working pilotly with people like Luminosity at Microsoft is hollow core fiber and multi-core fiber. So, quick 101. Many of you are sure very aware of fiber. It's a single strand of glass, and you pass light through it. When you look at hollow core fiber, for example, what you do is you actually have a core in the middle, and there's just air in there. So the drag on there and the latency that you can then achieve when you pass light through that is significantly improved. Why is this interesting for AI? Well, if you think about London or Amsterdam, where there's a moratorium of power where you can't build any more data centers today because of the government lockdown on that. But if you've got power somewhere else in your country or in another region, if you can extend that out from your DC campus using hollow core fiber, and the latency is almost identical or very similar to what it would be if it was in the metro, but push it out maybe 100 kilometers or 150 kilometers, that's the application where people like Microsoft and others are really investing heavily to look at how they can leverage this and build out those campuses and extend it from those traditional markets. Another innovation is liquid cooling. So this is where you have a non-conductive liquid that would go around the core semiconductor components, and then there's a heat exchanger. This works very, very effectively, and it's much more efficient than air cooling. However, as you can probably imagine, it's very, very expensive to retrofit existing facilities. But there are many pilots out there, both on those liquid cooling elements, but also fully submersing the servers as well. So very exciting to see how that develops. But there'll be a cost versus reward equation going on there for sure. And then the third innovation that we're looking at in Ciena, for example, is reducing the power and space. And Virginie called this out a little bit earlier on the panel, where our latest generation of modems, the WaveLogic 6, which can do 1.6 terabit per wave, takes up a significantly smaller footprint in power and space in comparison to, say, 3 generations ago. And I know it's a little bit small on this chart, but you can see several generations generating the same amount of capacity, but even looking at the space, you can see how big of a difference that's made in those few generations. So we talked about power, we've talked about space. We need to talk about the third element of my trifactor. Let's talk about the connectivity. So initially, let's talk about the subsea cable landscape. So according to telegeography, there are 16 core cables across this region at the moment, many connecting back from Europe, down into Asia, down through to Africa. But obviously, there's a significant amount of investment going on with 7 new cables building out, again, in similar areas as well. So a huge amount of investment is going into building out that connectivity and that backhaul to enable those connecting all those data centers that we talked about earlier. But as I say, it's not just about submarine. It's actually around the terrestrial routes or the dry routes as well. And the reason why this is becoming more and more important is it's not particularly new, but it's well known now that 90% of the trans-European Asian capacity runs through the Red Sea. And that very, very narrow channel has a lot of challenges at the moment with the geopolitical situation. And so the hyperscalers and enterprises and others who are investing in building out their networks are acutely aware of that risk-reward profile. And they're now starting to look at alternative routes on the dry system, which you may have never considered before, or they're actually starting to consider a lot more. That could be Muscat to Salalah. We talked about the SN1 launching today. Obviously, there's a number of routes, both north, south, east, and west through the Kingdom of Saudi Arabia. And also, very surprisingly, is, if you go rewind the clock a little bit, is we're now starting to look at capacity going through Kuwait, Iraq, and into Turkey. So these are new routes that are being explored, and it will take a significant amount of time for those to come online. But these strategic routes are going to be more and more important as part of the overall mix as well. So we've talked a lot about the compute elements. Let's talk about the network. That's why many people are here today, right? So if we look at the network element, there's this virtuous cycle that's going on at the moment where we're putting more data into the cloud. There's adoption of more cloud services, adoption of more AI. That's generating more data. And this virtuous cycle is just carrying on and on, creating more and more data. And the interesting thing that therefore happens is it basically exponentially increases the amount of bandwidth that's going to go over the network. So historically, data globally increases anywhere between 20 and 40% depending on where you are in the world and the application you're using. And that's really represented by that pink growing line there. But the interesting element is because of this virtuous cycle, this purple blocks are where there's a huge amount of increase in the amount of data. And so according to Omdia, by 2030, nearly 2/3 of the network traffic will be AI. And a vast majority of that is going to be driven by video and image content. So let's have a look at that in a little bit more detail. Let's have a look at the two core domains of how that will, and why they will impact networks in different ways. So the first domain you have is the training domain. So that's what you hear a lot about in the press at the moment. That's the OpenAI training, ChatGPT 5, for example. And that's all about sucking as much data as you possibly can into this typically one location. If you take ChatGPT, they have one data center, Microsoft data center in Northern Virginia. They're doing all of that training there, and then they create their model. Once you've got that model, you either take that and then distribute that locally, or you take a lightweight version of that model, and then you put that into your inference domain. And the inference domain then is all about how the user, you, me, enterprises, governments, interact with that model. So you put in your live data, it gives you a prediction and provides you that response back. And obviously that's then this virtuous cycle where that information also gets fed back into the training domain as well. What does that mean in terms of traffic then? So in terms of the training traffic, it's all about big, massive pipes ingressing data into that data center. And that's to take involved the vast volumes or the massive volumes of often very spiky, but not very time-sensitive data. Let me give you a real-world example here. There's a startup GPU as a service company, and their day one of opening, they bought two 400 gig services, so 800 gig of waves into their data center. And that's just a startup. Now, they think that they were going to double that within 12 months. So it's really big, fat pipes, and that's a great opportunity for particularly the wholesaler organizations in this room today. The other domain, or the other piece of traffic, is on the inferencing side. And so that's where a lot of it is low bandwidth and not particularly interesting, I suspect, for many of the wholesale providers. My little ChatGPT video, very minimal amount of bandwidth needed to do that. However, the interesting dynamic here is multimodal data. So that's where you have very extremely sensitive and very sensitive, to sync and jitter and the latency. And that's where you have the augmented reality, the AR, VR, XR goggles. And I don't know if anybody's tried them, but if you have any latency on them and it's rendering in real time, it can actually make you feel physically unwell. So it's really important that the data center and the access to that data is very, very close to that user to minimize that latency. But the other element here is those users have vast amount of data. We were playing with the Apple Vision Pro a couple of months ago, and we were testing the bandwidth on them, and we realized that one device was pulling 1 gig of symmetric data, which in its own doesn't sound like a lot, but if you can imagine your household where you've got 2 adults, 2 children, they've all got one of these devices, you multiply that by the street, you multiply that by the metro, all of a sudden you've got a lot of data, symmetric, that's aggregating to run these Vision Pro. Now, I know it's still very, very early days for those, but you can see the way this is going. And don't just take my word for it. This is a real world example. So this is The Outer Worlds. This is a blockbuster movie that was created 100% by AI this year. And this really shows the movement from very static content to dynamic content. And when I mean static content, many of you, I'm sure, have traveled today or in the last couple of days. You've been on a flight, you've watched a film or a movie on the plane. You've got to your hotel room, you've sat down, you've opened up and watched, open up CNN or BBC or World News. That's static content. That's delivery one way. Dynamic content is all about interacting with that story, and it gives you a different version of that depending on your needs, your requirements, what you're looking for from that content. And obviously that is then rendered in real time. And so again, that latency becomes incredibly important, and that proximity to where that processing is happening. Now, the core two I talked about a second ago, the training and the inferencing, they are real world examples that are happening today. There's a third one, and I purposely put this on a separate slide because this is still very, very early days. But the interesting thing is we're now a couple of pilots that we're seeing across the world where we're seeing distributed GPU clusters. So let me unpack that for you a second. So that's where, say you can't get enough power or space in one data center, so you're actually putting your data center cluster across 2 or multiple sites, and you have a high-speed capacity between the 2 of them. And the one pilot in particular in Texas, they needed 42 terabits of capacity between these two individual sites. So obviously there's a capacity challenge there, but actually more important and more interesting out of the pilot they found is they needed low, most importantly, stable latency. For example, if there was, say, 2 milliseconds between those two sites of latency, the moment that you got a little bit of jitter and it went up to 2.1 or 1.2 or 1.9, that knocked the model out. It has to restart the whole training. Very, very, very expensive, very costly. So that's why we're getting, there's only a few pilots at the moment, and we're aware of about 3 globally, but you can see how these are going to be, you can see more and more of these deployments in the coming years. And that's creating an opportunity for micro data centers. So not these massive gigawatt, multi-gigawatt data centers that we're seeing in places like Norway, in Kenya, in North America, but actually sub 1 megawatt data centers that you can put into a container. And we're starting to see these startups like Deep Green. So this is the example you can see on the right-hand side of the screen there, where they're deploying these micro data centers and they're using the excess heat from them to heat swimming pools or district heating systems. All well and good, but the challenge that you have is, okay, I've got space, I've got power, but back to my trifecta issue, you don't have connectivity. Don't know about you, but I haven't seen any high-speed capacity fiber going to my local swimming pool anytime soon. Maybe you do. But you can see how this is evolving and there's opportunity here. And if you do have those sites that are very close to the fiber, I think there's going to be a big opportunity for those companies involved. Another particularly really interesting topic is sovereign AI. And this, again, was touched on a little bit this morning in the keynote panel, where essentially what we're having is that you might be doing your big learning in, say, Norway, for example, or maybe in Northern Virginia, but actually your interaction with that model, so your inferencing, you don't want that live data to leave the sovereign boundaries of your country. So I think we're going to start to see more and more of these environments where you're having a deployment, sovereign AI deployment very locally, either to do the training or to do the training and the inferencing. And I'll give you a real world example of that at the moment. So you may or may not have heard of a company called Lidl. Lidl are a very large discount supermarket or grocery company based in Europe. And they're a German company, and they went to the usual hyperscale, the cloud providers, and they asked them to move some of their physical infrastructure. But they didn't believe that they were going to get, their data was going to stay within the boundaries of Germany. So they set their own company up, provided cloud services to their own company. And they did it so well that Siemens, Bosch, Daimler, large household German names, have now started using Lidl for their cloud deployments. Lidl is now debatably the second largest cloud provider in Germany. It's crazy how this is developed from this. And this is taken massively away from those traditional hyperscalers. So what is all of this? If I pull this all down to what does this all mean for opportunities for service providers in this room? Well, for me, I think there's 2 core opportunities. The biggest one where we see what we call extreme growth, that's the green mark on the top there, is where you need to get those vast amount of data into that training domain. That's where you need 400 gig services, 800 gig services across both the metro all the way through to subsea core. Getting all that data into those training data centers is going to be really, really critical. And we're starting to see service providers starting to bring real services, so AI Connect type services in this region, in North America, Asia, and I think there's going to be an example of a European one very, very soon. The second one, I think I would describe this as high growth, but still a good opportunity, is in that east-west traffic in the metro and the edge locations. And that's really where you need that symmetric to cope with that symmetric 1 gig traffic with the Apple Vision Pro. And it needs to be very much that east-west rather than more traditional north-south traffic. Good opportunity there, particularly if you've got metro assets and access assets. But I think where the extreme growth is going to be in the core of the network, and there's plenty of opportunity to be made for inference traffic as well. don't just take my word for it. We did a study on this earlier in the year where we looked at the perceived barriers of AI adoption. One of the areas obviously was lack of understanding. Obviously, budget constraints was a big element of that as well. But actually, when it comes to operators thinking about upgrading their networks, there was a lot of interest in, say, 800 gig, 400 gig. Now, I said I'm not really going to touch too much on the network operations element, but obviously that's an important part, and that's called out in the survey here as well. So if I'm thinking about my predictions for AI and the subsea connectivity and the community we have here in the room, very tight. I almost should have teed up the panel before me because I think they stole a slide before I came on. But it's all around data centers are not going to get built in those traditional locations. They're going to be built where there is power and space available. And it's not necessarily where users reside. So as a consequence of that, it's going to be all about the data flows to connect up those locations and make sure that all of the domains, whether it be subsea, core, metro access, everybody has access to those locations. The other element that we've not really touched on too much today is on idle compute. Once you've run your model, your GPUs are in theory sitting there waiting. So I think what we're going to start to see is it's very efficient to be able to move those AI workloads into different idle compute areas. And that's obviously going to create an opportunity for network providers because you need to then transport that data to those individual locations. And as a consequence of that, that's where the disaster recovery and redundancy elements are going to be a really critical moving forward. So my final takeaway from this is, look, we all think that AI is going to be a massive opportunity for our industry. Let's be honest, the hyperscalers ate our lunch when it came to cloud and data center deployments. Let's not let this next wave of opportunity be the same. Let's use this opportunity to be the value creator and generate revenue from this trend rather than be the bottleneck. Thank you very much for your time. Happily take any questions, obviously be available at lunch as well. Thank you very much. Any questions? Okay.
Hi, thank you for a very nice educational and informative presentation. I am the CEO of a telecom company, and one of the areas we're looking to investment into computing power, and originally also worked in the hydropower sector.
Mm-hmm.
Do you know what's the average cost of power per bit? Have you any chance to look at it?
Yeah, so it depends. The cost per bit, I've got some data that I can share with you offline. But what I can share with you is, for example, if you look at Saudi, for example, it's about 25% of the cost of the Western Europe. That's how much energy costs. So you can see how people are going to be moving a lot of those workloads to this region. In terms of the power per bit, obviously it depends on the network and things like that. But obviously you can take that offline and answer that question for you specifically.
Okay, thank you. Because I thought the Gulf has to both cool it a lot, but also it's still expensive.
Yes.
And there are places where you have hydropower, which obviously comes from the mountainous areas. So I was trying to do the comparison, but thanks. We'll talk offline.
Yeah, perfect. Thank you. Any other questions?
Yeah, thank you for your nice presentation. I'm having a question about the connectivity.
Mm-hmm.
So is there an easy translation of the data center power in megawatts? How much capacity required for connectivity? And there is a kind of how many terabits is needed for this many megawatts?
Yeah, there's a number of calculations out there, but it varies vastly. So the hyperscalers are starting to put together a lot of sort of models around that. But typically what we're seeing is when you build out these AI training models, probably 70 to 80% of that traffic stays within the data center, but that does mean that 20% is then moving. So I think you can sort of reverse engineer it. Again, I don't have the numbers to hand, but you can sort of, they say it depends on who they are. Microsoft have got some very, very large estimates for that. Oracle probably a little bit less. So it depends on who you are, but typically say it's about 80% of that data is staying in the data center, and 20% is actually then leaving.
Thank you.
I think we've got time for maybe one more question.
Hi. there's been a lot of talk today about the fact that the uptake in AI is at 90% in the US and 6% in Asia, and then the rest for the rest of the world.
Not take up, it's the where the investment.
Where the investment.
Yeah.
When do you see that changing, and how do you see that changing?
Well, I think just sort of showing that slide I showed earlier about the data center boom that's happening in the Middle East shows that I think that's starting to shift. And the Middle East is not only the only location there. You look at places like Norway, for example. Google are building a 680 megawatt data center, one data center, 680 megawatts, because there is space, there's power, they have great connectivity. You're seeing similar investments in places like Kenya, where in the Rift Valley, you dig a hole and hot air comes out. So very sustainable, very, very cheap power, and the connectivity is getting better and better and better there with things like To Africa and the various other cables. So is it going to be 80% next year? Maybe, let's see. But I think because of those investments and they're tangible investments, these are not just theoretical, real world investments, I think you'll start to see that shifting away from the US in terms of total spend. I think that's all we've got time for. So thank you very much for your time. Really appreciate it. Obviously, I'm available afterwards. So anybody wants to have any further chats, and appreciate the GCC, the CC community for inviting me to speak today. Thank you very much.